is managers need to be more technical. We all know of managers who maybe the last 10 or so years, they probably got a bit less hands-on. They were good at hiring and building orgs, and they can actually have a relatively good career at big tech. But those days are gone. Managers now have much smaller orgs because AI can do a lot of the work. And so as a manager, for the same amount of scope or business impact, you actually need to understand the technical details more.
Welcome to Tech Teams Today. I'm Lucas Mendes, CEO and founder of Revelo. Today, we're joined by Ken Kao, VP of Engineering at Rad AI. Rad AI is an AI company focused on radiology. Their goal is to empower physicians with AI to save physicians time, reduce burnout, and improve the quality of patient care. So to start, Ken, welcome to the show. We'd like to start by having our guests walk us through their background and journey. So could you tell us, maybe start by saying how you started out at tech and expand a bit?
Yeah. First of all, thank you, Lucas, for inviting me on the show. Super glad to be here. I'm happy to share a little bit about my background and how I kind of got into tech. Part of it was actually a little bit more coincidental than probably some of the stories I've heard about someone who's been programming since they were 5. So I was born in Taiwan and I came to the US when I was in high school. I always wanted to do material science and I was really interested in renewable energy, specifically around nuclear, solar, etc. So I did some of that research in a lab in high school, and then I went to college. At college, what I realized is that because I was international, I actually couldn't legally stay in the US unless I get a working visa. And even then, most companies don't sponsor green cards. So part of the reason I actually moved into software was because that was the easiest way for me to get a green card. Now, obviously, I was very lucky. I realized that early on, freshman and sophomore year, and turned out I actually did fairly well in my computer science classes. But a big part of that was really, I always wanted to go back to something more mission driven, whether it's healthcare or energy. And I realized I couldn't do that if I get kicked out of the US. And so software was by far the best way to do that. I was very lucky. I joined a very mission driven company after college, after my master's actually at Palantir. And they got me my green card. I did good work there. Things were really good. And it kind of just like took off. I stayed in Silicon Valley, moved to New York for a couple of different companies. And, in 2019, I actually moved back to San Francisco. I joined Airbnb for a couple of years. One thing that I think is worth noting is that, when you stay a long time at different startups, you learn how startups operate. However, the sort of paradox is every startup that wants to stay small and nimble, that sometimes like to trash talk large companies, they dream of one day becoming a big company, right? That is the ultimate parameter for success. And so if you constantly go from startup to startup, if you're lucky, they grow big, that's awesome. However, if most startups that don't go big, then you actually haven't really learned how to truly scale. So you don't actually have the experience or the know-how to take a startup from stage A to stage B or series B to series C. And so once I realized that, it's almost like a light switch went on. Hey, I can't just keep going from startup to startup. I have
Yeah.
one experience at Palantir that, it was about 500 people when I joined and 2,000 when I left. Other than that, it was different startups. And so I went back to Airbnb to learn how to scale teams. We took it to IPO. Then I took a look at my portfolio and I realized, you know what? I want to join a startup as a head of Eng, but I'm not quite there yet because I haven't really managed infrastructure teams before. I've done a lot of data work. I've done a lot of product work, but not really infra work. So I went to Meta to work on infrastructure for AR/VR. And then after a couple of years, now here I am at Rad AI.
That's quite a story. Just to recap, you had early internships at large corporations, HP and Facebook, then Palantir, then Airbnb, then back to Facebook for the AR VR stint, and now running engineer at Rad AI. Tell me a little bit about the roles that you had there. You spoke a little bit about the scope. You hadn't done infra before. How about management? When did you start managing people? How did you expand into the management role?
So my first job out of college was actually in the Taiwanese Marines. And after boot camp, I got offered 2 paths. One is I could join the Marines reconnaissance team. The other one is I can become a software engineer in the Marines. So I chose to be a software engineer, even though the other one would have sounded way more badass now thinking back. So I chose a software engineer route. So my first quasi-management role was really, as I demonstrated myself, I had to manage 3 other software engineers in the Marines. So that was not quite the same as Silicon Valley. And the reason is because over there, on one hand, you kind of have to do a lot of yelling to get people to do what you want. It's a lot of sticks, not a lot of carrot. But on the other hand, you don't have people being super entitled. People don't complain about, the kombucha in our fridge. There's not enough flavors that I like environment. So when I came to Silicon Valley, you can probably imagine my shock. You went from that sort of culture to here, where I remember when I joined Palantir, someone next table to me at dinner told me that the lobster this week did not taste as well as the lobster last week. And that was just shocking to me because I was in the Marines and food was terrible there. So I started out as IC at Palantir, worked for a bit, and then at one point my manager realized I was a pretty good tech lead, and so asking me to run projects, but also start adding people. I don't want to say random people, but people that I didn't know or people that are not on my projects as my mentees. And at one point, I think I had 6 or 7 mentees, and I was thinking, "What is going on? Why do I have so many mentees? And they're not even on my project." It turns out he was grooming me to be a manager. And so he wanted me to be a mentor first, prove it out, and then become a manager. I think it was probably end of 2015 was when I officially took on the management role. I started out with 2 direct reports, and then continued on through that path at Palantir. The interesting thing, though, is that a lot of people think switching to manager is a one-way door. You go into management, you can't come back. I don't agree with that. I actually think going back and forth will make you better at both jobs. So after Palantir, I went back to being an IC at Flatiron Health because I wanted to learn more about AI, more about data processing, more about the technologies. I did. The funny thing there is 6 months in, my manager said, "I think we should want to move you back to your manager." And so the thought process here is you moving back and forth is a good thing. And that's probably lesson number 1. Lesson number 2 is something that my manager at the time told me when I was leaving is he said, "Ken, uh, management is your spike, right?" I don't know what that says about my engineering abilities because they didn't make any mention of that. But he said, "No matter what you do, don't give up on your spike. You're giving up on your spike by going somewhere to be an IC." And I didn't really truly understand that back then because I was still young and I thought I could do anything. But in retrospect, it was really good career advice because if that is truly your spike, people will recognize it. And even in the new job, 6 months in, my manager wanted me to be a manager again. So I think the way to think about it is really identify your spikes and ask for your manager, ask your mentors, and really double down on your spikes. That's truly how people make an impact, whether it's management or IC.
That's a great take on it. A lot of people listening to our podcast are aspiring engineering leaders. What advice would you give for those people that are starting out today in a career in tech? I think for those that are really aspiring to become managers in the future.
So I actually was invited to a Eng Leaders dinner where I gave a talk, and I think there are 2 things that is going to change in the tech industry because of AI. Number 1 is managers need to be more technical. We all know of managers who maybe the last 10 or so years, they probably got a bit less hands-on. They were good at hiring and building orgs, and they can actually have a relatively good career at big tech. But those days are gone. Managers now have much smaller orgs because AI can do a lot of the work. And so as a manager, for the same amount of scope or business impact, you actually need to understand the technical details more. So I would say as a aspiring manager, there's obviously the obvious things. Hey, be good at the people side, take care of the people, learn how to do hiring, learn how to do performance management, all those obvious things. I think with the less obvious thing is I see managers, senior managers, even directors needing to be a lot more technical going forward than they did the last 10 years.
Yeah, I think we spoke about this the last time we were chatting. You said engineering leaders will need to be more involved with the business, and business
Mhm.
leaders are going to be more technical. Maybe shifting gears here in a world where AI is changing everything. How do you actually do that?
Yeah, so this is actually a really good question. And I think first we have to break down what is an engineer? What does an engineer do? A lot of people think about engineering. I know you don't think that way because we've talked about that. But a lot of people think about engineering is your job is to write code. You go out and you churn out code. But actually, writing code is literally probably, if you ask most top engineers, they would say writing code is probably the most boring part of the job, right? The most interesting part of the job is solving problems. And writing code is a way to express your solution in a way that can be applied in the real world. But it's the problem solving part that is exciting, not the code writing part that is exciting. And so now in the new world with AI, we have found increasingly that AI is actually really, really, really good at writing code. If I want to incorporate a new library, I have to look up a bunch of documents, go in there. There's going to be some bugs and some errors, and I have to probably spend 5 hours just getting my Python environment set up. If you have AI, they can figure out all the dependencies for you, set up a pretty well working environment, and at least get some prototype out. So AI is actually really good at rote tasks of writing code. So where does that leave the human? That leaves the problem solving. And problem solving, not in terms of figuring out which library to use or which function to call, but problem solving in the terms of how do I transform a business problem into a technical problem, right? Today, maybe my goal, let's say at Airbnb, my goal is I want to build a feature such that hosts can figure out their pricing. Now, at the same time, I want to be able to recommend pricing to hosts based on my ML, right? Now, a a business requirement might be we need to help hosts be better at pricing. But someone in the business side may not know exactly how to do that. As an engineer, then you have to think through, okay, well, there might be multiple paths. There needs to be one path, which is the host can manually set the pricing. There's another path, which is we have an ML model. Well, which model should we use? Like maybe the host can decide they want to have more volatility versus less volatility. What type of toggles do you allow? And maybe, even if you use the model to set the price for them, the host needs to have a way to override. Like as an engineer, you have to understand how to break it down to technical problems, and then the machine can go do it for you. Now, in 10 years, maybe you can just give it a business problem and AI can build the whole thing for you. Maybe, maybe not. None of us know. But as of, I would say, probably the next 3 to 5 years, it is still critical for the human being to understand the business and break it and convert it into technical problems. And that's where AI comes in.
Yeah, I completely agree with that. I think that even if in the future we're able to feed the machine just a business problem, how you feed that problem to the machine completely changes the type of solution that gets used, right? So
Mhm.
you're talking about better pricing. Are we trying to maximize number of bookings? Are we trying to maximize margins? Are we trying to maximize growth? They're different business problems, right? And
Yes.
even being able to specify that has to go through some form of interface, right?
Mhm.
Today, that interface is code. We're adding layers of abstraction and we're going to interface with in some other way. I really like that approach. Now, specifically to managing engineering teams, what do you think separates a great engineering team from one that's just okay?
I think a great engineering team can actually understand the business problem and then think to how they can optimize on the business objective. Engineering team that's okay, even if it's strong technically, is someone that can take features and requirements and build a solution that fits your feature, right? And what I've seen many, many times over in my career, because I used to work a lot with banks when I was at Palantir, is in a bank, you have business people sponsoring an engineering project, and they don't even call them engineering; they call them IT, which has a different sort of implication and connotation. They sponsor a project, and then they set up a spec for the IT team to build out. The problem is the IT team doesn't actually have the business context because they're not given any of it. So they're just optimizing on building out based on the spec. Now, we all know we're humans, we're not perfect. If you write a spec, you're not going to think of every single possible edge case. So the IT team is not incentivized to think of any of them. So they're just going to build by spec, and then they charge the business team for the cost. If there's any bugs, they go back and fix it. It becomes more of a bit by bit sort of whack-a-mole situation, and then projects get delayed. And then that's why you see a lot of big banks buying fintech companies because they can't build software. Now, you look at the opposite end of the spectrum is Palantir, where you have software engineers forward deployed going out to the customer, understand the business problem. So then instead of being given a spec, you think about the business problem. So as you build, when you find out, wait, I haven't thought about this edge case, I haven't thought about that edge case, because you have the business context, you can incorporate it into your technical architecture and build it the right way on the spot. Now, again, you're not perfect, but when you find issues, you can go back and fix it because you have the full context. And so this is something that I think Palantir pioneered really well. And it was part of the reason why Palantir consistently was able to out-deliver compared to other competitors that are traditional government contractors.
I think this relates to something we were discussing last time we met. You spoke a lot about autonomy and how you think that those teams should be. You should create, as an engineering leader, you should create the incentives for that autonomy to exist. I think you said that your goal should be to get yourself out of a job, right?
Yeah.
And how do you actually do that in practice?
So I think in practice, really, the way to work is you need to identify the right leaders. Autonomy has to come with accountability. You can't just let people do what they want and then you don't hold them accountable for it. So because autonomy comes with accountability, you have to identify the right leaders. Once you identify the right leaders, and leaders does not mean they have to be management. Like in my case, every director that reports to me, I pair them with a principal engineer, and those people are partners. Um, because you have a technical leader and you have a people leader. Once you identify those people, you hold them accountable for a particular outcome, right? Not for the how, but for the what. Right?
Mhm.
You explain to them the why, you share with them the what, and then they decide on the how. So By doing that, they are thinking about a higher level outcome, and then it's their sort of autonomy and their creativity to come up with the right way to achieve that goal. I think the classic example is Facebook, and some people argue Facebook or Meta does it a bit too much, but this is a good example of autonomy. Facebook might go to a team and says, "Here's your KPI. I want you to move this metric from A to B." So, for example, I want you to be able to move, let's say, click-through rate from 0.1% to 0.3%, right? Now, the leader doesn't tell you how they should do it. You should do it. The leader would just say, "This is the number I want to see," and then the
Mhm.
team brainstorms ways to do it. And this is what really, really pushes the sort of autonomous culture. And that's why Facebook is very famously bottoms up because you have each team's accountable for certain metrics and then they go do it. Now, there's obviously counterexamples of how that if you overdo it, you might have the opposite outcome or other companies that don't do it that way. But I do think that philosophically, having teams be accountable for the outcome really promotes the autonomy and promotes the creativity for them.
But I have to guess that some traits of the people that you're working with, I mean, the people that are part of your team, they actually can make or break this kind of approach. And
Mhm.
what do you think the ideal traits are that you're looking for when you're building this sort of autonomous team?
Yeah, and so I think great leadership and management, you kind of have to apply it to the right set of people that you have, not the people you wish you had. So, for example, when I was in Taiwanese Marines, I was not giving anyone autonomy because they're not going to go there and own the outcome. They're there to just like do a job, right? And so, applying this sort of approach would not get the outcome you need. Now, on the flip side, when you join different companies, different people come up with different background, they might have different characteristics. I think for me, what really matters is really want to have a behavioral interview with them and ask them to walk through projects where they truly own the outcome. Can they explain the business impact? Can they explain the why? Can they explain the origin of a particular project? Some people they dive directly into code or into technical architecture and how to solve technical problem, but can they actually understand the business context? This is something that actually is really important at Rad AI when we interview leaders to be able to discuss a project all the way from the business context, the origin, down to sort of the technical architecture and the technical trade-offs. And if you can't do that, then maybe you're not the right person to be owning the outcome. You can take a different job. But if you want to know the outcome, you need to understand the full end-to-end business and technical context.
Got it. And as someone who interviews a lot of people and recruits people, do you see that the vintages are changing? I mean, what are you seeing when it comes to engineering talent today versus, say, 5 or 10 years ago?
I th- I think there's definitely a lot more engineering talent out there nowadays because computer science became much more popular as a major. I was catching up with a friend of mine maybe last week. I think 2014 was when at Stanford, CS became the most highly declared major, and for class of 2014, that is. And then at Penn, I think it was class of 2017 or something like that. So the CS became the most popular class. And so there's more and more people out there, which is great. I think in terms of the actual quality, I haven't seen too much of a difference. I know some people like to say, "Oh, Gen Z's this, Gen Z's that." I mean, I don't think a college grad now is better or worse than a college grad from 5 years ago. I think they're very similar. However, I think what we look for is different. For example, let's say 30, 40 years ago when you're coding in C, we didn't really have debuggers. When debuggers first came out, some people didn't want to adapt to debuggers. Now, the ones who do use debuggers will be so much more efficient at the job. Right? Now, 15 years ago, we have Stack Overflow. There are people who insist, oh, the hardcore engineers read Linux man. We don't do Stack Overflow. That's cheating. But hey, the ones who use Stack Overflow, they can build a product and prototype much quicker. Now, what I see now today is not so much in the raw intellect that has changed. It's more like in the approach. People who adapt to LLMs are much more efficient. They can come up with a solution much quicker. In our take-home project at Rad AI, I explicitly tell candidates and our recruiters, I'm okay if they use LLMs. As long as they can explain how they use the LLMs, why they use LLMs instead of them coding, it's a perfectly reasonable answer to say, I use LLM for this particular way to integrate library because it would save me 2 hours of time. Perfectly reasonable. What I found is there are some people who are able to take advantage of the LLM shift and think outside the box and use LLMs to augment their engineering work. And those people are the ones that are going to stand out.
Yeah, I think it makes a lot of sense because at the end of the day, they're going to be using that tooling. They'll have that tooling at their disposal on the
Yeah.
job, right? So they might as well use it in these characters. But just double clicking on that very quickly, are there specific use cases that you're seeing for LLMs in your engineering team that you're more excited about, such as documentation, debugging, code reviews, or testing?
So what we found to be really good is when you spin up a new project, it helps you save a lot of time figuring out boilerplate code. Whether you want to use new libraries or new integrations or figuring out function calls, I think that's a big win. Another one is around test automation. So it can help you find different leakages in your code. That has been really helpful. And the third one, we're still kind of just experimenting. We haven't officially had everyone use it, is writing PRs. So Codium, for example, we don't use it right now, but I played around with it on the side. Codium has a PR agent, and it's able to actually give you all the changes in your pull request. And the description, on average, is more detailed than what a engineer would actually write down. So that has been very useful. It's helpful in debugging if you can use it at scale, right? So, for example, as an engineer, maybe you're in there to fix something. Usually, while you're investigating and fixing something and you see some other thing that's broken and small, usually you just go ahead and fix it. It's not big enough for you to open another ticket or open another program. You just go ahead and fix it. But when you actually submit the pull request, you probably don't even remember about it or you don't bother to think about it in your description. Codium, for example, would catch those changes and remind you, hey, it should be there. And this is going to be important because, hey, who knows, 3 years down the line, maybe there's a SEV, there's an incident and an outage, and it's because of that one shift or one change. So that's something that I think not as many people I've talked to have been using, and I think that could be helpful, especially in times of incident reviews or SEVs.
You just mentioned that in the middle of the last decade, CS became the most declared major in a few universities. How do you think that's going to change? What do you say to young people about that are thinking about learning how to code? How do you see the future of a career in coding for those that are really starting out?
So this is where it depends on if you believe your future career is in coding or in problem solving, right? If it's just in coding, then I think it's going to be tough because most coding in 10 years, 15 years might be done by machines. But if your goal is to understand technology, understand how to break problems down with technology and solve technology, then I actually think there's still a bright future. Think about even at this day and age, I think it was maybe 20 years ago, Mark Andreessen said software is eating the world. Look at how much of the physical world is still not being eaten by software yet. These transformations take a long, long, long time. I just came back from Taiwan. A lot of places are still taking cash, and Taiwan is a relatively well-developed country. So many things are being controlled by closed loop systems like our bridges, our tolls. There are so many things that are not digitalized yet. So if you imagine anything that's physical could in theory be digitalized, you can then imagine anything that's digital can then be transformed by AI. And so I think there's definitely still a lot of opportunity, and we're just at the tip of the iceberg. And it's one of those things where people don't think about it, but once you actually start paying attention, the fact that so many things still has to be done physically means there's opportunity for software. And the fact that all those things could be in software means there's opportunity for AI.
Right. I want to shift gears here a little bit and shift from AI to another trend that has really changed how we manage teams recently, which is remote and hybrid teams. Today, your team is distributed. I wonder if you could talk a little bit about the structure of the team, but also how did you guys get there? When you joined Rad AI, were you guys already distributed? Have you always worked with distributed teams? Talk to us a little bit about that.
So some of the shifts happened before I joined. So the company was originally founded in Berkeley, California, so in Northern Bay Area, and they were actually in person. And then when COVID happened, they went all remote. And then during COVID, all the hirings were remote. So when I joined, it was full remote already. There's been discussions on whether we want to bring back hybrid or go to an office. And generally speaking, I've been pretty against this shift for a couple of reasons. Number one is that most startups don't have the sort of brand awareness or brand prestige, if you will, in hiring. So we have to offer other things to attract talent. Now, if you look at the sort of call it top tier tech companies, like let's say Google, Meta, OpenAI, Anthropic, they are enforcing a hybrid model. They're making people go back to the office 3 days a week. They are picking the most expensive places, for example, Bay Area, New York, and Seattle, to find the best talent. Most startups are going to be unable to compete with them in those regions. And so if you force people to go to the office and they can go make 5x or 10x of OpenAI, it's a really hard sell. Now, if you're young and you have a mission, you're idealistic, and maybe, But if you have a family, you have a mortgage to pay, your kids need tutors and go to, I don't know, maybe go to private school, it's a much harder decision to make. And so what I found to be successful is there's still a good chunk of people who are just as talented, but they don't want to live in these high cost areas for any reason. For example, we have a super talented researcher, AI researcher that's in Minnesota. Like he is probably qualified and can get a job at any of the frontier research firms. However, he needs to be in Minnesota. And so we end up hiring people from Minnesota, from Florida, from other places, from maybe from DC, Maryland. These are the people we are able to hire, and we can give them relatively competitive wages because they're not in the high cost area. And we can offer them the flexibility of remote in a way that aligns with their lifestyle. So I think that is something that it really just depends on how much pull and how much brand awareness you believe you have. I've also seen startups that enforce in person, but they're different, right? Maybe they were founded by someone who's a superstar. Maybe like the founder is already a big brand name, and just showing that name, everyone's going to want to join. I've seen that, and so and that's happening right now as well. So I think you kind of have to be very intellectually honest with your own brand awareness and brand prestige in a way that I've found a lot of startup operators or founders are just not willing to admit. They're not willing to admit that they don't have the brand awareness or prestige to attract the best talent if they were to go toe to toe against an open AI, right? I think you have to be intellectually honest. It doesn't mean you're in despair. It means if you're honest about it, you can figure out other ways to mitigate this disadvantage. Maybe it's your mission. Maybe it's the culture. Maybe it's the remote flexibility. Maybe it's something else.
Yeah, that's not an easy one to swallow for many founders out there, I'm sure. Um, I wanted to stay on the same tone and ask you, you have another opinion on engineering leadership that you think runs contrary to conventional wisdom? Like, do you have any opinion that goes against the grain when it comes to managing engineering teams?
Oh, interesting. That's a really good question. This might be somewhat controversial against the grain. So, I think a lot of people in the startup ecosystem, they like to talk trash about large companies. They'll say, oh, a Google engineer is lazy. They don't know what they're doing. They can't do anything outside the Google ecosystem. Oh, like Amazon engineers this, Meta engineer that. But what I found actually is all things equal, generally speaking, tier one companies have higher caliber engineers than non-tier one companies on average. And what I mean by that is if you were to grab an arbitrary set of 10 engineers from Meta, they're probably better than your arbitrary set of 10 engineers from startups. And that's just something that I've found to be true. And I've talked to quite a few startup people who, frankly, everyone I've talked to were able to admit it off the record, but nobody really wanted to go on stage and say that. Now, it doesn't mean that any single startup, they don't have good talent, right? Like, this is just a statistical average. So what does that mean? And what does that mean as an eng leader? Like, what's the takeaway here? I think the takeaway here is we need to let go of a lot of our biases. Like, so many people like to say, oh, well, startup people don't know how to do X. Is that, no, that's not true either. This person who's founded a startup, maybe he built Bigtable at Google. So I think a lot of these generalizations and biases needs to go away. And we need to evaluate each individual more independently on an individual basis. Like, I've oftentimes heard my CEO say, oh, a big company people move slowly. And I would push back and said, oh, at Meta, we move much faster than Rad AI, right? Now, that's not because Rad AI is slow, it's because we're in healthcare. So of course we should move slower, right? We should be more deliberate. But the fact that Meta is 1,000 times larger and can move faster, it doesn't mean that big companies move slow or they move fast, right? NVIDIA, you might think they move slow, but every year, every 6 months, they have a new chip. Now that's pretty damn fast. That's faster than a lot of software companies, and the chip is significantly better. Like a lot of software companies, every 6 months they have something new, and then it's like an incremental improvement. NVIDIA, every 6 months they have a brand new chip that actually is significantly better, right? Like you could argue that is moving fast. And so I think the key takeaway is that I would try to let go of a lot of these patterns because I found that to not be very useful, and that we should really just evaluate each person on an individual basis and let go of these sort of generalizations because they're just not really applicable when all you care about is hiring the 5 people, the 10 people, the 20 people. That's a drop in the bucket among the pool of candidates.
That's a great point of view. Ken, thank you very much. How can our listeners stay in touch with you? Is it X, Twitter, LinkedIn?
Yeah, I'm on Twitter, Ken K616, or on LinkedIn. Happy to answer any questions or happy to receive any reach outs.
Great. Thank you for watching Tech Teams today. I'm Lucas Mendes, CEO of Revelo. Today, we're joined by Ken Kao, VP of Engineering at Rad AI. Thanks so much for your time, Ken. I absolutely love the chat. Personally enjoyed a lot learning more about your journey. And everyone, don't forget to like and subscribe on Spotify, YouTube, and Apple Podcasts. Feel free to chime in with your thoughts in the comments.